Okay, so here we have a dice manufacturer claims that a novelty dice he produces has the probability of scoring 1 to 5 are all equal, and the probability of scoring 6 is 2 times the probability of scoring any of the others. Find the probability of scoring a 6. So what we can do here is we can do a discrete random probability table. We've got 6, 5, 4, 3, 2, 1, and this is what we're getting. The probability of x is going to be p, 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 and 2p. And if you remember with these ones, what we can do is the sum of all of these probabilities has to add up to 1 in a discrete probability table. So we have got 5p plus 2p is equal to 1. So p is equal to 1 over 7. We need the probability, find the probability of scoring a 6. So the probability of x equals 6 is 2 over 7. How do we get it? There is 1, 2, 3, 4, 5 p's, and there's 1, 2p. Add it all up, we get 7p is equal to 1, and we get our probability there. Pay close attention on B. Find the probability of scoring more than 2 6s when the dice is rolled 5 times. What is the probability of scoring a 6?
2 over 7.
Will that change?
No.
Are we rolling the dice a set number of times?
Yes.
Fixed probability, set number of trials. What probability distribution is this?
Binomial.
This is a binomial probability distribution. What is the variable x? X with a binomial probability distribution. You always start by saying what x is. Some of you, Moe, you have to pay attention. I'm marking you wrong if you use calculator notation this time around on the mock. I'm going to mark it wrong. You always have to start off by saying x is the number of ... Always x is the number of ... X is the number of ... Now x is the number of what in this question?
X is the...
What are we doing 5 times?
So x is the number of rolls?
No. What are we wanting from the roll?
Oh, so x is the number of rolls that is a 6.
X is the number of 6s. Always is the number of. Then you have to say this. X is binomially distributed with 5 trials and a probability of success of 2 over 7. You will get it wrong. Sorry, if you say, I don't know, what is it? Binomial PDF bracket 5, 2 over 7, 2. This will be marked wrong on your mock this time. This will be marked wrong. I'm not marking this correct. Your method is written here. So we need the probability that the probability distribution x produces a 2. We need 2 6s. No, sorry, we don't. We need more or equal to 2 6s. So.
Well, actually, it says more than 2 6s. So what does that just mean?
It says more than 2 6s. You're right.
Greater than or equal to.
So it would be great. We would start with greater. We would start with greater than 2, which is equal to the probability that x is greater or equal to 3. So I think the calculator notation for this one, which isn't accepted, would be 3, 5.
Okay.
So let's do that on the calculator.
I got 0.0.
We need menu, probability distributions. We need a binomial CDF.
Yes.
Menu,
5,
probability,
5,
probability distributions, isn't it? B.
yes,
B. Number of trials,
5.
5.
Oh, I put this one.
Probability of success,
2/7.
2/7. Lower bound, 3. Upper bound, 5. Our probability is 0.1. What's this? Sabina, what's this to 3 significant figures?
0.145.
Also,
Because it's 2 significant figures. It's just embarrassing. So you have to split the figures.
Which equals 0.145. 0.145. Okay, find the expected frequency for each of the numbers that are claimed true. So we need the probability of each one times the number of trials. So the expectation of getting a 6 is going to be 350 times 2/7. So we're doing 350 trials, and that's times 2/7. That's going to give us 100. The expectation of any of the other ones, such as a 5, is going to be 350 times 1/7. So the other ones are all going to be 50. So we can add here that the expectation for each one of these is going to be 50, 50, 50, 50, 50, 100. So then we go into and calculate a list. We need n as our numbers and our expectation. So here we got 32, 57, 47, 58, 54, 102. We expected to get 50, 50, 50, 50, 50, and 100. So let's see if that, I made that common mistake, look, where you don't press enter on the last one. Got to make sure you press enter on the last one. So to do the test, we need menu, statistics, stat tests, we need the goodness of fit test, our observed things is N, our expected is F. How many degrees of freedom do we have? There's always going to be 2 columns, so you only really need to know the number of rows. There are 6 rows, so the degrees of freedom will be 5. This gives us a p-value of 0.984. So we got 0.0984. What's our significance level?
5%. Okay, the P is highest number.
So this is greater than 0.05. If the P is low, reject the hope. So what is the conclusion?
There is insufficient evidence to reject the non-reject.
Fail to reject. So insufficient evidence to reject.
I think she's cool.
All right, that's it for today.